Hi guys, Vincent here. I'm with my partner Stella. For our project, we've modeled electrical loads of two buildings from the facing visit.
We wanted to evaluate and understand the energy performance of commercial buildings during the operation phase as an effort to lay foundation in the concept towards future sustainability and growth.
The aims of our investigation are twofold. Firstly, we want to study the relation between building occupancy and electrical load demand.
The second aim is to investigate if there is sufficient renewable energy contribution towards electrical supply and provide strategies that the university can adopt to increase local renewable power contribution.
This is our model to address our first aim from the Chamber of Mines building. This panel is the user interface. The user is required to specify the day and month for the simulation run and specify the school day type. If it's a semester weekday, then the user must select the day of the week and then the user will select a combination of floors to simulate. Here we have a simulation run button. As an example, we have simulated the whole building for a Friday on the 4th of March. These are the simulation run results from the sub-models that makes up the whole model. In graphical form, we have the results plotted on this page. For the occupancy model, we have present occupants in blue and active occupants in orange. Then we have the casual and passive thermal heat gains within the building. For the temperature model, we have outside temperature plotted in blue, and the rest are the temperatures within the 4 zones that we have divided the building into. For heating and cooling demand, we have plotted the chillers, power consumption in blue, and plant rooms, power consumption in orange. Then we have a plot for the lighting power demand in blue and appliance power demand in orange. And finally, we have the building total power demand plotted here. From these spreadsheets, that's where we import our climate, building, and occupancy data required for the submodels.
Moving on to our second task, which is modeling journey labs. This model took advantage of the predictive nature of activities taking place in the building. The information was obtained and displayed on the screen. The model was implemented using a C++ program, and the data needed for the program to run were stored in the file as shown below. For instance, the data for the Actim lab, the bar fridge, which consume 150 watts. There's only one bar fridge, only one fridge is operational. The Actim lab is on the ground floor. This is the number of minutes it runs per day and the time at which it gets switched on. When the executable is ran, data is stored in the power consumed, the txt and power summary. This data is then exported to an Excel sheet, which is used for plotting the graphs. This graph, for instance, shows a great proportionality between the power consumed and the occupants in the building. In the morning, as people are getting to the building, the power consumed increases, and afternoon, after lunch, it shows a great increase, which signifies the commencement of laboratories, and it starts decaying as students complete their labs.